Yeah, I skipped streaming yesterday because I had to catch up on some work. I don't know if you saw my tweet yesterday. This one right here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 PRs in yesterday morning. During my when I would be streaming because I had to catch up on some work. I went freaking ham, dude. Work? What is that? I had to get this stuff done. I was starting to block. Well, I wasn't blocking people, but it was stuff that needed done that just needed to get done. And, yeah. Oh, man. I had no idea that was a function. All right. Yo, I'm pumped. I'm getting some freaking graphite swag from that tweet yesterday. Um, Dude, why is this always busted? This is always freaking busted, dude. It never loads. Either way, I'm getting graphite swag sent to me. I'm so excited. I freaking love graphite. It's such a good tool. All right. Let's get our RFC-1035 open. And let's go over here. Let's run some updates. Jump in here. I can show you my my dot tool. I don't think I showed that on stream the other morning. Let's see here. Let's hop over to config. We can do dot. I have nice completions. Let's see here. Dot link. So we have all these commands here. We can do dot dash dash help, and it'll list all my commands that I have, right? Init, update, all this stuff. Has examples of how to do things. I can do dot summary for what I've been recently working on in my dot file directory. Listen, I just let Claude go on this, and I'm not upset about it. The bash code it wrote is actually pretty clean. If we go look at this thing, this is pretty clean bash. Look at the symbol outline. It's not as clear as I thought it would be. Yeah, this is on Git. It's super nice. Like it generated all the fish completions for me. So let's do dot, what do I have under package? List, remove, update. I can just do dot package update all my stuff. I do not use Nix anymore. I wonder what the difference between the dot update function is. Okay, so it just pulls. Oh, it restows too. Okay, cool. Cool. I can do dot doctor and shows me if my environment's set up correctly. It just wasn't worth it. All I really needed was brew and stow, and then I made this tool that you're seeing here, this dot tool, and it does everything I need. Like I can benchmark my shell, see how fast my shell startup time is. So like how fast can it's just like everything I need and want. I can be anywhere. Like let's say I go to code, I can be like dot edit and it'll launch me into NeoVim editing my dot files. It's really nice. Yo, what up, JMS? Let's see here. Anything I need to care about in these updates? I don't think so. Lewis snip never freaking updating. Drives me crazy. All right, let's go back to our DNS resolver. So I left I know I left a to-do note for myself in here. To do, yeah. So the part we're working on today is the compression of names. Let me get this going. Okay, we'll do that. And this should be twit. There we go. Test. Perfect. I just used ChatGPT to chat with a support agent at a retail store and push to get a full refund for a microwave I bought 3 years ago that broke. That's awesome. You should have recorded that, dude. That could go viral. All right, compression. Message compression. Here we go. All right, yeah. So let's see here. To do, when hitting a pointer, which a pointer are these two bits back to back. When hitting a pointer, take a subarray of the current byte array from the offset of the current pointer offset, e.g. 20 to 44. So we would take this slice, read labels until null terminating byte, and then continue. Ah, clever. Managed to get a full refund too. That's insane. Like, how did you? How did you? I'm curious about how you did that. This is a different Tmux Pain tech support. So, were you doing the speaking, or was ChatGPT doing the speaking? Ah, so you were having it listen and then tell you what to say? All right, we can get rid of the has encountered. The has encountered isn't going to work for this. It was a clever idea. So if we hit a pointer, we want to take a slice. So we'll say, I don't even know what to call this, but we want data view dot, can I get to the buffer? We don't even, yeah, buffer dot no, I think we want the UN8 array dot subarray, and we'll take the subarray, and we want to slice from the, so if it's the pointer, we want to get the next so to get the offset, if we want to get the pointer offset, actually, I might have had like the correct logic here before. Offset +2 bit mask. So this byte is the full thing. I bit shift it to the right twice. I almost want to do the opposite as that. So we want to do pointer offset is, hey, I saw your X post on DI services with effect, which was pretty cool. People there are really self-reporting that they only write JS slop. It's very, very true. Like I have some empathy with them, right? Like when I first saw effect, I was super skeptical. And like to be fair, the tweet on the dependency injection stuff was not, I was not intending to reach the audience I reached with that. I was intending for that to reach people who are using effect. The dependency injection part of effect is truly like the most novel part of effect, and it is the part that is nothing like there is no other pattern in TypeScript that really works like that. You're basically using like existential types to build up a context, which it's truly not hard if you take a minute to look at what's going on. You're basically just creating a hash map where the keys are associated with types that you can access at runtime. That's like what it is. But yeah, people, it's so funny. People look at that code and they're like, oh, this is slop. And it's just like, I want so hard to just be like, Show me the code you wrote today, because I guarantee you it's fucking garbage. It's so hard to write good TypeScript. Even the best TypeScript devs in the world struggle. Yeah, exactly. All right. So we want to get the pointer offset. We can bit shift the current byte, right? So we've got the byte right now. We're looking at, we're not looking at the full byte. We really want to get, we want to get, we want to do data view dot get uint16. So we basically want to grab this whole uint16, right? This is two bytes here, and we're gonna bit shift to the left 2 to drop these off, and then we're going to bit shift and zero fill back to the right to essentially drop these. That's the idea here. Get uint16. We're gonna start from our offset, and I think this takes little endian. That'll be false. We're working in big endian. Same, Buffy. Same. I've been implementing EffectTS system into Parserator as of last night. Gave me a really bad headache. Oh man, I'm so used to working with EffectTS stuff now that like it's so second nature, and I couldn't work without it anymore. Failed to get inlay hints. I don't think inlay hints are working. They're not disabling. Weird. Huh, we'll have to look into that. I don't know why that's broken. All right, so we have the pointer offset, and then we want to bit shift to the left 0x02, and then we want to bit shift back to the right 0x02. I think something like that. What is this upset about? I'm just gonna right quit out for a second. And let's go back to where we just were. Why? What am I doing wrong here? All right, what? So this should be a number, and then I should be able to bit shift that number Can't I? Isn't the triple unsigned bit shift? Am I crazy? I feel like I've asked this question left shift, not valid operator. Oh, it's probably 1 and 2. Yeah, I'm a silly goose, chat. Being a silly goose. It's too early. So I want to make sure that's right here. So let's create ourselves a, what is R right now? So let's say R is, let's say we have a new U. R is going to equal new uint 8 array, and we'll say it's going to have 2 preceded by 20. That's not even the right way to do that. No, that is. No, it's not. We'll just use a binary. So we'll have 0, B, 1, 1, and then we need 20, which let's do 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Then we need 20, which is 1, 2, 4, 8, 16. And we want to then do 4. 1, 2, 4. That should be equivalent, right? Let's say this is going to be, just call it X. That should be equal to this row right here, right? And if we bit shift it by 0x02, and I do put these in parens, why can't I jump to the end of the line? Is that really not going to respect that? It's annoying. .2 string base 2. Oh, I need to bit shift by not 2. We need to bit shift by 14. Right? I don't even know if that's right. How do we 0 pad it? Zero fill, bit shift. Yeah, okay. That does become 20 at least though, right? Yeah. That gets us the value we want. So that is the right logic. I need to like save this screen layout here. Windows. Can I save this? I know this has custom. Stream layout. Ghosty. Can I just have it use what's currently on the screen? Thank you, Raiders. What up, Robotic Head? Create window. I just want to use what I currently have. Window management. I've got a raid and run, got a 10 p.m. meeting across the Atlantic. Good luck with your meeting. Thank you for the raid, Robotic. Appreciate you. Welcome, Raiders. I'm going to spend another like 30 seconds on this, and if I can't figure that out, create. Whatever. All right, it's fine. All right, so we want to bit shift 14 to the left, and then we're going to bit shift back 14, and that will give us our pointer offset, right? So we bit shift 14 this way, and then we bit shift 14 back. That cuts off this. Shouldn't bit shifting 2 drop it off? I still feel like X 0B 10.2 string 2. Oh no, because it's pushing zeros from the right. Right, it's, yeah, I'm dumb. Oh, that is weird though. It's not just... Huh, okay. All right. Uint 8 array, and we're gonna take from the, I think this takes an offset. Is this inclusive? It is inclusive. The end is exclusive. That actually works well. So we can do pointer offset. All right, what does the language this uses? If this uses language for the pointer, I want to use that. The domain name. All right, we'll just call it pointer offset. And we're going to take up to the current offset. So that should give us the slice we were talking about. Is there a third parameter here? No. So this means when we encounter our pointer, right? If we encounter the value 3, at the front of at the start of a byte, we hit this pointer, that comes here, we get a subarray from here to here. And then we'll keep processing Or actually, shit. Well, actually, that's okay. Because we're grabbing more than we really need, right? We really just need to grab to this null terminating byte. We don't know where that's at. So like really slicing up to here is fine, and then we just stop processing when we hit this. Yeah. Okay. I think I need to, I'm trying to think if this would be easier to write with recursion. I want to write a function that basically I want to write a function that is like take until null byte or terminating. What do they call it? Do they call it a null byte or a terminating byte? Where's the name parsing stuff? The Node.js standard library DNS resolver has a bunch of footguns in it, and I want to add a DNS resolver to the Effect platform package. The original idea was to just write it around the Node standard library and the Button standard library and Deno's DNS stuff, but Node's DNS resolver just isn't, it has weird nuances and doesn't have the data I want. So it turned into, I'll just do it myself. So now we're writing a DNS packet parser to do it ourselves. Terminate, is it null? Yeah, I think it's zero length octet. Yeah, we'll just call it I think we call it a terminating. What do we call it up here? Terminator. Okay. So let's write, let's just move this down and we'll put this here, center that. So this will be take until terminator. And we can actually make this a little generic. We can take a uint8 array, which will be a uint8 array, and then we'll say terminator, which will be optional, and it will be a number, and it's going to equal 0 as a default value, which means it's going to be pissed because we don't need that. Jump into here, prevent that from going to the next line, and we want to let what do we want to call it? I guess it's taken. And it's a byte array. Do I have a byte? No, but I do have a uint8. EffectTS, here, I'll get it. If you go to effect.website, that'll be what you're looking for. It's like a standard library for TypeScript. It has dependency injection, it adds virtual or green threads, it adds typed errors, all sorts of stuff. So let's say while let terminator found, we'll say this is going to be false, while not terminator found, we're going to basically we want one more piece of state. This will be offset. It's going to equal 0, and we want to make a data view. Data view, and we're going to pass in the uint8 array, and then this will be uint8 array dot, I think this is offset in length. Yeah, uint8 array dot byte offset and uint8 array dot byte length. Do that. That one's buffered. So now we have our data view, and we can get byte is equal to data view dot get uint8 at the current offset, and we'll do plus plus, and we'll say if byte equals 0, we'll say terminator found is true. And really we can just break. Whatever, we'll just continue. And otherwise, we will taken dot push byte. This isn't 100% right now. Because we really don't want to take until terminator, right? Like we want to ignore, making this generic is not actually probably what we want. Where the hell is the compression? 4.1.1. Here we go. Because we don't want to take the lengths. We want to take labels. Take labels until terminator. So let's write another function. Now we can decide to break this out in a second. So the way this works for anyone that hasn't been here, this datagram right here is storing 3 domains in it. It's storing f.isi.arpa. It is storing foo.f.isa.arpa, and is storing the apex domain, just ARPA. And you can see that here, the way this is encoded is it says every row is 2 bytes. So this is a byte, this is a byte. this this first byte right here is saying, hey, the next part of your domain is going to have a length of 1 byte. So you say, okay, I'm going to read 1 byte. You read 1 byte, you get F. You move forward and you see, hey, the next part of my domain is 3 bytes. So then you read forward 3. I, S, I. Then you hit 4. You say, okay, I'm going to read 4 bytes. You get ARPA, A-R-P-A. There's a bunch of data that's not shown here that you read in for like the rest of the question or answer data. And then you'll hit a null terminator, and then you're on to the next domain. And it says, hey, the next part of this domain is going to be 3 bytes in length. F-O-O. We get foo. Then we hit this double, this byte of length, or this basically value of 3 at the start of this uint16. And that indicates that we're going to hit a pointer. So we basically get the next value, 20. This is a pointer back in memory. And the pointer says, go to offset 20 and start reading again. So we hit foo, F-O-O, go to 20, we hit F, and then we read through the domain again. So that's how we parse in foo.f.isi.arpa. So that's how like they do compression in this in these DNS packets. So the thing we need to do now is we have this logic already up above for hitting like the length and then parsing the labels. So let me go grab that. That's going to be in here basically. Then a name. Yeah, okay, so for naming wise, like each of these is a label, and then the full thing is a name. So we really want to read a label. So let's write a function to just read a label, right? So let's function read label. Actually, we don't really need to do that because we know take labels. We can just do the same thing. And how do we type? When we're building up, yeah, we don't include that. Okay, yeah. We just want the labels. We don't need the label lengths. So this would be found the null terminating byte. Otherwise, we get const label length is going to be That's actually the byte. We can get for int let index equals 0, index is less than byte, which is the length, index plus plus, and we basically just do data view dot get uint8 offset plus the index. Really, this should be 1. That's not actually what we want though, right? How do I do this above? We figured this out the other day. I need to split screen here. When we read the question, because the question does the same thing. When we read the name, this is what we want to do right here. Basically this exact logic. So we get the length. So let's rename that to length. We don't need to touch the offset, but we do want to break. I guess we do want to do this, right? We'll just return that. So if the offset, oh, we don't have the AST here, right? We'll just throw an error here. That's going to say throw, we'll just do that for now. So if the offset plus 1 plus the length is greater than the uint8 array length, oh, we overrun the buffer. Yeah, that's a good check to do. Then we get a subarray of the offset plus 1, that makes sense, to the offset plus 1 plus length. Because it's starting there, it's exclusive of the end. That makes sense. Yeah, that makes sense. That will read the name. Yeah, so what that will do is basically that's saying from, let's say we hit this, that's not a good, let's say we're reading ISI here. Length in our case will be 3, right? We check to make sure that the current offset, which is 22 plus 1 plus the length doesn't overrun the buffer, so it's safe to read. And then we take a subarray, so we'll say from here, and then we'll say offset plus 1 to length. So that'll be from here, and that'll read to here, but it's exclusive of that. So we really just read these, and that gets us the labels. Yeah. Good morning, Mizzy. So we have our value, and I'm doing well. Yeah, we want to do the value check because we know that the length can't be greater than 63. Feels like we could do that. Well, yeah, we'll do that here. Dodo. And really these Damn, Izzy, that was close. So we've got that. We push the value. Huh. I said we have a UN8 array, but we should have just used actually UN8 array. That was silly. How do we do this over here? What do we type it as? A mutable name array? It's really like, I mean, that's actually true. Mutable name. We don't need to do that. Take labels until terminator. This will be taken, can be, this can be renamed to labels. Or really, this is name. And we can rename this as read name. We almost need to I need to keep track of like where the offset would be to make this generic. I need to return more information because like up here, we get the offset. How would we do that? We could return like, we could have like a type that's like name. Well, we can derive the offset, right? Like to get the, maybe we can do this dynamically. No, that's like more work. But really like to determine like what the offset should be, you could be like get name length with offset, get name offset. and you would take a name, which is a name, and you would go through here and you would say, let offset equals 0, and then for const byte of name. This should be a uint8 array, right? Yeah, it's not a byte. For uint8 array of name, you would say offset plus equals uint8 array dot length. uint8 array dot length so that would be the single bytes. Actually, we have this logic somewhere. I'm positive we did this logic right here. Or something like that. So it's really just the number this would be name.length, sorry, and then it would do that. I think that is how you would get the offset, right? So let's say we had like, we'll use foo.example.com, right? So it'll be 3 FO, yeah, FO, FO, or this is what like a name ends up looking like, right? Foo example and then this will be com. So to determine like what the offset in the normal uint8 array would be, we have 3 because there's 3 items. 3 plus the length of this, 3 plus 7 plus 3. So we have what, 9 plus 7, 16. And the actual underlying byte array ends up looking like kind of like this, except it's all contiguous. So you get rid of that, you get rid of that, that, and this is actually 3, 7, and this is 3. I'm not, I don't know, I'm skeptical. We need to make those strings. Or really, it doesn't matter. We can just like, oh my God, is that not a repeatable? I could have just counted this, right? I'm being an idiot. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. We got the length right. That is the right way to get the name offset. It's technically extra work. Like we could return like a tuple. Where it would be like offset is a number, and then name is name. This is starting to look like Golang chat. Are we properly updating our offset everywhere? I don't think we want to move the offset right there. So let's come down here. We do want to do this though. And now let's make a tagged error class buffer overrun. Extends schema.taggedError, and that takes buffer overrun type string name buffer overrun the schema. We'll say this is going to have the buffer schema dot uint8 array from self, and then we'll have I don't know what I want to put on there yet. We'll just throw the buffer on there. And then we can make another error called invalid label length extends schema.taggedError invalid label length That'll be invalid label length, and our schema for that will be label, which will be a uint8 array. And then we can just give the length. And in here, we can do return effect.fail, and we'll do new buffer overrun. And this is going to take the buffer, which will be the uint8 array. Yeah, we can get rid of this type up here. I'm still not convinced that's what I want to return, but it's fine.
Hey, did you put the trash out?
What?
Did you put the trash out?
Ooh. Whoops. Forgot the trash. Guess I'm going to the dump. And then down here we will do return effect.fail, new invalid label length. And that's going to take the label, which is the value, and the length is going to be value.length. In fact, we don't even need to put the length on there, because we have the label right there. All right. I still don't love how I'm managing the offset here. Like, we could pass an object in and do mutation. Don't love that. I don't really want to return another object. I don't want to read over the, I mean, this is, I guess it's fine. Let's switch this up so it's going to be name and offset. All right, so we can do that now at least. And that means we can replace this logic here theoretically. We should be able to do this, and we should be able to say const qname and offset is equal to read name, and we pass in the data view dot buffer. or maybe not, the uint 8 array. And that's an effect. Parse.type. I guess we could pass this the AST. And then go here. This gets the AST, which is a schema.ast. And then down here, we can actually do, rather than using these errors, we can actually use the errors above. These parse results. So that will become, that will go here then. And rather than QName, we can just say name overruns buffer there. And we can go back and we can grab this and we'll yoink there, drop back down, that goes here. And then we want to do a parse result. It's like parse result dot succeed, and this will be the name and the offset. Yes, you're gonna want to wrap every promise. So effect has effect.try promise, right? You'll use that. There are some like helpful patterns where like I'll wrap full SDKs. It's like called the use pattern, and that ends up looking like what is this? I want to go here. Yeah. If we look at like what would be a good one, YNAB probably. I certainly use it in here. Yeah, like this use pattern. So this YNAB thing is a promise-based client SDK for like a SaaS I use. So this is like, this returns promises, right? If we look like client.user.getUser, that returns a promise of a YNAB user response. So we write this use YNAB thing. So this takes a function which accepts a client and an abort signal and returns a promise. And then we basically call that function inside of try promise, and we catch it here, and we'll wrap it with our own typed error. And then we can use basically this use YNAB thing to build up other APIs. You can see here, here's where we use it, right? We say use YNAB, we get our client, the client comes out here. This is all promise based, but if it rejects, like basically this converts promises to effects for us in a safe way without doing a ton of boilerplate. There are elements of functional programming in Effect, but there's also elements of object-oriented programming as well. What's up?
I took care of it, don't worry.
Thanks. Sorry, I went to bed with a headache last night.
You made me.
Yeah. Recycling didn't go today, right?
Mm-mm.
When I get back Oh, I guess since recycling will go on Tuesday, I was gonna say we have a lot of cardboard. I was gonna take it to the dump, but
I mean, you can take it tonight.
yeah, if we go walk tonight, I'll take it
I have book club tonight, but
if the weather's nice.
you and your mom will go.
Yeah, and I'll drop all the cardboard off at the dump, and then we'll go for a walk right there.
Okay.
I think I saw that you texted me. I didn't. It looked like you sent me a picture.
I did. You replied.
Did I?
Or reacted, I thought.
Did I? Oh, yeah, I did. Okay. I want her to go in so bad.
Same. But she knows it's there. She knows there's food there.
That's good. It probably means she'll like anchor home base down
Right.
there, right?
So we're gonna make it even better by putting even more food, more water, so she knows to stay in this area. Because do you want to know she manually turned off her tracker?
How does she do that?
Somehow there's a button on it. Somehow, some way, her
Probably
other
scratching
collar,
it.
either scratching it, her other collar, something. But yeah,
When's she
So-
due?
July basically. So
Yeah.
we have time. Puppies will make it either easier or harder to catch her. Depends on how she is as a mom.
Yeah, hopefully she just bunkers down around this area and ends
Yeah.
up in the trap one night.
It makes me so nervous though because right behind this tree line is
Is the-
540.
Yeah.
Thankfully, like there's a fence there, but she could she could get around it if she
Yeah.
wanted to. It's not like it's super secure.
This fucking dog. Barrel. Freaking barrel.
Frickin' barrel. But yeah, so I might leave for work really early tomorrow and stop and refresh the trap before
Okay.
I go. But
Sounds good.
does my hair look okay? Did it dry weird?
Yeah, your hair looks great.
Okay. I just didn't feel like doing it.
Like right here might be a little weird.
I know, because like
Bend?
why is my hair straight but curly?
Yeah, that's the only spot I'd fix, but it's not even that bad.
I'll just tuck that piece behind me. If I do that, is it fine? I'll just tuck it.
Yeah, that looks good.
I'll just bobby pin it back.
Cool.
That's all.
Thoughts on returning effect either into the data channel of React query to persistent types. So I talked about this in my React Miami talk. Hold on. Yeah, close this door quick. React query and use SWR are kind of annoying for using. Basically, you're gonna have to do a bunch of manual work. I would wrap here. Let me slow down. The problem with returning all errors into the data channel when you're using React query, TanStack query, use SWR, is that you will forego all of like the retry and specific error handling stuff inside React query because it looks like it's a success and it might cache it. So what you really need to do is you need to like have an extra layer in your fetcher where if you need to leverage the retry mechanisms of use query, or depending on something, you basically would like catch tags on the errors that need to trigger that behavior, and you would throw and then let React query deal with it. But then like the actual errors that don't need to kick off that behavior, you would return into the data channel. And it's still not great. It's just not like a pleasant experience. Yeah, they squash the error type. You can provide an error type, but it's not type safe. It's unsound. You could technically like write a wrapper around it where you have like you copy all of the values from use SWR and or from one of these things, and you like runtime type check the error channel. Like you could do that, right? Like where you have your typed errors and then just like always would a union like a known exception to it, and then just like runtime parse it with the schema. I don't know. We're dealing with this at work too, because we have to use SWR for parts of our UI, but we're starting to use RPC, Effect RPC. That will be shipping with the new domain search. All right, back to our DNS resolver. And yeah, no problem in the overview, Plankton. Should really be like parse name and offset. All right. So we get up here and we get result. Is that an effect? I really don't want to turn this into an effect. No, it's just an either. So we should be able to do either. Probably use parse result since it's already here. Dot is. What is up with those? Otherwise we get
describe the world.
okay, maybe what? What is happening here? Did we break? What did we break here? Okay, now it's good. What? If parse result dot is parse error result, we should be able to say, do we get all right, so we don't want to use that. We'll use an either. Is left. Left is the failure, right? Yeah. Or do we just return? I think we can just return result. Otherwise we get const value, or we'll get name offset is result.write. Yeah. This is actually QName. And we'll do offset plus plus. It's a constant? Oh, you bitch. What? How's it possibly undefined? What? That shouldn't be possible. This should return a parse result dot parse result. I guess this should return an either dot either, where the left is a parse result dot parse issue or error. What does this return? Parse issue. Or it returns a name and a number. Okay. This is so stupid. This is so stupid. I'm about to just copy and paste this code and not care. If I have to copy and paste it, I mean, we could just do a cast. I know it's a safe cast to do. Or do I have this backwards? No. I do have it backwards. Gasp. That's why I was upset. And then we get rid of this. And now that's happy. And that means we screwed up the... Oh yeah, either has like... I forgot that either has the weird flip-flop thing. Technically, it's like the type of either is like either, right, left. It's really stupid. Drives me crazy. All right, so we can reuse this at least. So what is this upset about now? What's wrong with your font? Nothing's wrong with my font. LNR? It's cursive. I have my comments are italic. I'm using Mona Lisa.
Functions describe the world.
Yeah, you're not tripping. All right, so we have that now.
Functions describe the world.
All right, I want to see if our tests still work. Fun run test. All right, we failed there. Not enough bytes for Q type and Q class after Q name. So let's actually undo this quick. And let's comment that back out and make sure this works here. Where did our offset go? Under question, I just want to grab U down through U. Do that. And let's see if that fixes our test. All right, so we do have a error that decoded simple domain name. UN8 array from self to Q name. Name label overruns buffer at offset 10. So we didn't change anything here. Well, yeah, we did. Okay, that's good. We just had a bug in our parse name and offset. So why do we have a bug there? I'm using Mac OS X. Yeah, this is just OS X. We didn't need to increment the offset. Which means that should probably fix our bug, right? I think that should fix our bug there. So if we go back and we do this now, let's try running the test again. Yeah, that was the bug. All right, so we got parse name and offset working. Memory of a 2-element tuple versus a object with 2 properties in JS. Yeah, that's what I thought. Okay, so we'll keep it like that. We'll keep using a tuple, which is fine. And we can get rid of this block of code now. And we'll say increment to next byte. Increment offset to next byte. All right, we can close that. And now we have a way to read names. And we can use our name reader in here. So we're here. Thank you for the read, star, or raid. Jesus. Can I do this from here? Let's see if I can get it. Star Ansible. Shout out? Oh. Shout. Unrecognized command. Shouldn't that be an actual command? Anyway, Star, how was your stream? Welcome, Raiders. We are working on writing a DNS packet parser. Parse them packets. All right, we've got our, so we read to 20 to the current offset. So we have from here down to here, and we really want to read to here. So let's just try that. Const name equals, we'll say result equals parse name and offset, and we'll pass in our, I don't even know what to call this. Not look back. What do we name this thing? Fuck it, we'll do this. Let's not even give it a name. And this probably needs a AST, which will be a schema ast.ast, and we'll pass that down through. We'll clean up all this later once we have everything working. We get the result, and if we, if either dot is left result, we'll return parse result dot fail result dot left, which will be a parse issue. Otherwise, we can get the name and offset from our result at the right key. Name offset, and we want to what is the array method we want right here? This is not a queue name. It's both for fun and learning, and we're also going to try to get this merged into Effect Platform as a DNS parser. And then I also want to use, once this is merged into Effect Platform, I want to use it at work. So it's like a little bit of everything: learning, fun, open source, kind of work, but not really. Let's see here. We want to do name.concat. No, not concat. We want to like push name. What? Oh. What do we call this? I don't know what to call this thing because it's like a look back, but it's not really a look back. What does the spec call it anything? Previous. That's a great name. Previous name, previous name and offset. Which I don't even think we need that. We don't even need the offset. We can just grab the previous name and we push the previous name. So we now can go FOO. We hit this, we hit 20, we go back to here, we read to here. And then we probably want to do you can get rid of this, just call this byte. 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 We'll probably want to increment our offset. 2, right? Because right now our offset's at 44. We hit the pointer. We read where we need to jump to. We jump, we read to the null terminating byte, and that leaves us off here. And we're still sitting at this. And then this is 2 bytes, so we need to jump 2 forward. And when we jump 2 forward, we have to read the rest of this structure. Yeah, and we basically want to do I think they're pretty easy to read. We can do read uint16s. Where's the structure of a resource record? Yeah, so we get the name. That's a uint16 read. That's a uint16 read. TTL is a we learned that this is a 0 padded 31-bit unsigned integer read. Okay. I'm thinking I want to I kind of regret making these nested functions now. I kind of want to do this all back in line again, which is annoying but I don't like passing around this AST. Yeah, I don't want to do this. I want to just go back and copy paste. So let's go back and go grab where we started right here, and we'll go back up to question, and I want to grab this part again, and I'm okay with copying this code because we'll figure out how we want to do this later. I think I've reached for abstraction too early here, and I'm okay with duplicate code. I do want to switch that though and put that down here. Move increment to the next byte. All right, let's make sure our tests work again there. They should. Yeah, cool. So now let's go back in here, and I don't want to, I'm going to take from U to U, and we're going to put this in line right here. This will be previous data view. It really feels like we could use recursion here, but I don't want to go down that rabbit hole quite yet. Data view pointer offset. And this is not, how were we passing that before? Hold on, I just confused myself again. So we pass that as a number. Oh, we take a U in. Here we go. That's what I wanted. That's what I was looking for. This data view is going to get const previous buffer previous uint 8 array, and then we go here, yoink that, and then we use previous data view, grab that, and the offset, this now becomes previous offset. I am shifted today. I'm so shifted. We've bit shifted twice today. No, 3 times today. It should be... Oh wait, in this case, we don't even need to keep track of previous name because we have that. We can just push into name. Yeah, we actually can. We don't even need that. Oh boy, this is like, this is complicated, chat. We can basically take all of this too, and well, this we can delete because it's not used anymore. Love deleting code, and we can do this and move this inside of this. This is going to be a resource record. This is my free time. I'd like to use this for some of my work ever so, but this is open source free time stuff. I want to get this merged into, I'm trying to write a DNS resolver from scratch to merge into Effects platform. And right now we're doing the DNS packet parsing. Okay, so we have this. We'll just jump down to the bottom and just do like a throw to do. All right, so I feel good about grabbing the resource record. All right, so after we get the pointer, we move forward to reading this structure. A variable length string of octets that describe the resource. The format of this information varies according to the type and class of the resource record. For example, that's an extra word. If the type is A and class is in, the ART data field is a 4-octet ARPA internet address. How do I figure that out? Should I launch my YouTube channel with a full development course, or should I start by creating short videos and reels to build an audience first, then release a course once I have followers? I don't know anything about building an audience on YouTube. I don't think, like, thinking about myself, like if I tried to launch a course 2 years ago before I had an audience, it would have flopped. But now I think I could launch a course, especially on like Effect or OCaml or something in that area, and I could be relatively successful. And that's because I've built a reputation for being known for this stuff. Oh, camel my camel. The RD length specifies the length of the R data. Okay, I was like getting super confused on like how do we get that? All right, so we hit that. And this would be a resource record in and of itself. A variable number of resource records where the number of records is specified in the corresponding count field. So this data is what is interleaved in these gaps here. So like there would be a resource record here, there would be the rest of the resource record here, there would be a resource record here, null terminating bit for the message. I don't understand, like can there be multiple? No, there's probably only one pointer. Okay, we'll assume that that's the case for now, that there can only be one pointer in a name. In order to reduce the size of messages, the domain name system utilizes a compression scheme which eliminates the repetition of domain names in a message. In this scheme, an entire domain name or a list of labels at the end of a domain name is replaced. Yeah, at the end of a domain name. It has to be at the end. Great, that's the thing I was getting caught up on. What up, Maniac? So given that, that makes life a little bit easier. So once we've read pointer, if it's not a pointer, we want to read names. ourselves to others. We basically need to repeat this logic, as annoying as that is. So let's rename this thing to, I hate this code right now. There's so much repeat, but like it's subtly different. And let's rename this byte. This is really going to be like terminator or length. No, that's not what it is. Byte. Yeah. So we take this part and we return that. That's going to be down here. Are you building an extension for EffectTS which can resolve DNS names compliant to? Yeah, exactly. And it will merge into, Effect has this thing called its platform package, which has a bunch of interfaces for doing things like HTTP, file system reads, sockets, logging, workers, like all this stuff. And then these are all interfaces, right? None of these are implementations. And then the platform, a platform is basically a JavaScript runtime. So you have Bun, you have Node, you have Deno, you have the browser. So then we'll go and implement the DNS resolver for Bun, for Node. We'll probably end up using the same one for all of them, but the browser is probably going to have to use HTTP DNS resolution. But yeah, that's the goal. What up, Mr. Maxwell? We are just working on message compression this morning, which is a fun problem. I really think I could write this using, we'll probably go back and refactor this to use recursion, but for now we're just manually writing it out. And this should be previous offset. This should be previous unit 8 array. This should like really never happen. We have a bunch of bugs in here. Previous offset. Then we loop back around. We get the next byte. Dude, state machines are fire, Nightshade. What are you talking about? And then we want this. And we'll do the same thing here. This becomes offset though. Or no, this is uint 8 array. Which, there's another bug. Right? No, we're good. Yeah, we're good. I need to like close the pointer. All right, so offset plus byte plus 1. That moves us so we would be at the end of this while loop. We move our offset to, which would put us here. Is that what we want? Hold on, I'm like super confused. We hit a pointer. We read all of the pointer. We push it into the names. If it's not a pointer, all right, let's just start here. I need to like walk myself backwards. I'm using Mac Camp. All right, so we're starting at 40. It's not a pointer. It's not a null terminating byte. That should be fine there. We take a offset plus 1. We get to here, and then we query, yes, we pull that. We're good. We push the value. We increase the offset to get to here, and we loop back around. This time it is a pointer. We get the pointer offset, which is going to be 20. So we parse this. We go back to here. We read the name data, or we read the labels up until this null terminating byte. When we hit the null terminating byte, well, let's say we don't hit the, let's go through this again. We don't hit the null terminating byte. We get the value, we do this, the previous offset plus that. We progress to there must not be a null terminating byte. So offset goes there. Almost like we almost want to break. Here. Yeah, I think that's what we want. Because like that would mean we read this, we hit this, we jump back, we read to here, then we break once we hit this, and we push the offset forward 2, because right now the offset's at 44. This would be 45, so we want to be at 46. Yeah, so that breaks us out of the loop. Where is this thing? Offset +1. Yeah, right? So that should break us out there. All right, so here we're at offset 46. And we're going to read type. So we would say const type is equal to data view dot get uint16 at our offset, and we don't want little endian. And then we would say offset plus equals 2, and then we would get the class resource class, and this would be the same thing. And then the TTL is a 32-bit, technically 31-bit unsigned integer that's 0 padded. Fucking stupid. So stupid. Do I have a parser for this thing yet? I have a uint31. Great. So stupid. So stupid, dude. It's the dumbest thing. Then we'll get TTL is going to be data view dot get uint32 at offset false, and then we'll say really, I can just say, I don't really even need that schema.
Speaks the gospel of the camel. I speak the gospel of the dunes. The sand is in my veins.
Thank you for the
Come ride a
sub,
camel with me today.
Defusol. Appreciate you. 8 months. Decode uint31. What are the options here? Errors. Should receive all parsing errors. Exact. I don't think we really need that. Can I get UN31 dot annotations dot is there any way to get at the between from the schema? Like, can I get at the AST? Whatever. Is there an is?
Speaks the gospel of the camel. I speak the gospel of the dunes. The sand is in my veins. Come ride a camel with me today.
I'm thinking of changing my Twitter handle. Interesting. Thank you, Roasted. 21 months, a true OG. All right, let's jump back down here, and then we'll say if not is UN31. So stupid. It's the dumbest thing. So stupid. Is it issue? What is the syntax here? Syntax is type. And this takes the AST, the TTL, and then a message. TTL must be a 31-bit unsigned integer received TTL. Okay, so we've got our TTL, we've got our resource class. Next we have const rd length is going to equal this will be data view oh wait, we actually have to we have to increment time to drink and derive. Margarita time. We need to we want to say offset is now plus equal 8. right? That's 32. There's 8 bytes. 8 bytes in uint32. Yes? No. 4. See you, Nightshade. Thanks for hanging out, man. This will be data view dot get uint16 on the offset, not little endian. And then we have the offset plus equals 2. And then the length. Our data, a variable length string of octets that describes the resource. So this is going to be a const, we'll say, yeah, const our data is going to be a new uint 8 array, and the length is rd length. And then I think there's like a copy dot buffer dot copy uint 8 array dot copy. We were using, is it set? But really, we don't need a new uint 8 array. We just need a subsection. It would be uint 8 array dot subarray. We can just keep using the same memory here. And we're at the offset. Right, that's where we start, right? Yeah, offset. RD length. Does that need to be +1? Because that's exclusive. +1. name type class is resource class. TTL, RD length, and RData. Did I not put RData on here? Oops. RData is a uint8 array. Schema dot from self. Can I just say this is a uint8 array? Copy diagnostic, AI chat, what's the error? That's not the error. Right. I actually do know what the error is. Parse result.succeed. There we go. Okay. Mr. Claude, it is your time to shine. Do we already have a Claude that markdown? We're just going to delete that and we're going to re-init. Let's come down here and we're going to go back into Claude. And we're going to do a init. Let's see what model we're using right now. We're on Sonnet. Yeah, we can use Opus for this. I use Claude Max. I have Claude Max reimbursed from work. In it. And we're going to have Claude write tests for our decode process. See if we can get this done before 10. While that's loading, let's go peruse the old x.com, the everything act. All right. Yep, that looks good. Yep, that looks good. Yep. 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 Yep, yep, yep. Yep. Yes. All right, so add tests for resource record decoding to at test. Add effect-based property tests. See how it does, chat. Actually, I want to give it some more context real quick. I want to give it the context. I'm going to give it from, oh my God, let me. Down through there. Make sure that the arbitraries / mock data conforms to the RFC 1035. Note that TTL is actually a zero padded 31-bit unsigned integer, despite what the spec says. It was later corrected. And then we need a slash. No, is it the normal slash? How do I give it a new line? Whatever, we're just pasting. No, I think you have to put a slash. I just forget which one it is, and I didn't want to lose what I had already. No. Yeah, it's like you have to just literally write the slash character and then press enter, and then it will give you a new line. Like you can go look at the docs for Cloud Code, and it's just the thing you have to do. I don't know. It's the thing. What is this jujitsu thing? I keep seeing people talk about jujitsu, and Graphite says they want to add support for this. Nope. So what is Claude doing right now? Bro, I have no idea what Claude's doing. This guy is struggling right now. I'm about to switch to Sonnet and just let it go, because Opus is being a dick. There we go. I want to map, if I could map my exit, if I could remap the exit key from escape to JJ, I'd be happy. I'd use it. This reminds me a lot of sapling. I have no idea. I've only seen it crop up lately. I just don't know why I would use jujitsu when I have it's not 1.0. It's similar to my workflow, but graphite, because I'm using graphite, I have so close to this workflow already for me that like I don't get a lot of benefit from learning this new tool, at least at the moment. Maybe it offers something at some point. I would probably use this if I weren't using graphite. That's what I would say. All right. So we added some tests here. Describe, resource record, arbitrary, yep, 231 minus 1, great. Generate a valid RD length. Mm-hmm. All right, let's go look at the code. And we'll go look at our test. We have errors here. Why? Void never unknown. Why do we get unknown? We'll have to fix that. I know. All right, we'll have to fix that tomorrow, chat. So that's where we'll pick up. I gotta wrap up here and get to work. Oh, it's unknown because the encode function. Right. Let's just run a test quick. First try. Maybe first try. What are we caught on that? It's probably generating some arbitrary. Is there a filter in here that's taking forever? There's only 2 filters and neither of them are new. Seems fine. I have no idea what we're blocked on right now. All right, whatever, that just ran for a minute. We'll commit and we'll say whip on resource record decoding. Push that and let's jump over here. We're gonna raid prime. Oh, tech support is streaming though. Or effect. Oh my god, who do we raid? There's so many people. I feel like we gotta do Maxwell. Maxwell's on the core effect team. Maxwell's great. Go show Maxwell love, everyone. Give him follows. Subscribe. He's the GOAT. Good friend of mine. Good friend of the stream.